So let us take a quick revision of what we have studied in the last lecture. So there are two types of complements. One is diminished complements. Another one is radix complement. So diminished complement is r minus 1's complement, and radix complement is r's complement, where r is the base of the number system. So we have discussed the nines complement of a decimal number, and the nines complement can directly be obtained by subtracting each digit by 9, and we can find out the resultant nines complement of any decimal number. We have done two examples for this. Like if we have to compute the nines complement of 546,700, now what we do here, we subtract each digit by 9, and the resultant is your nines complement of that particular number. So in the same manner, we'll discuss the diminished radix complement of binary number. In the binary number system, base is 2. So for binary number, r, that is base, is equals to 2, then r minus 1 is equals to 1. So we can say that the ones complement is the diminished complement of a binary number. So the ones complement of a number number n of small n bit can be calculated as 2 raised to power n minus 1 minus n. The formula is same as for the decimal number. Here r, the formula is r to the power n minus 1. Here r equals to 2. So we have written 2 raised to power n minus 1 minus n. So first we have to calculate the value of 2 raised to power n minus 1. Then we'll subtract the n from that particular value. Now take an suppose 2 raised to here 2 raised to power n is represented by a binary number that consists of a 1 followed by n zeros, as it was in case of decimal number. For example, take if n equals to 4, then we have 2 raised to power 4 is 64. 2 raised to power 4 is 32, and 32 is represented by 1 followed by 4 zeros. Then 2 raised to power 4 minus 1 will be 1, 1, 1, 1. In case of the nines complement, it was a sequence of n number of nines. In case of ones complement, it will be a sequence of n number of ones. So what we have to do, we have to subtract this particular number n from the sequence of ones. Now thus the ones complement of a binary number is obtained by subtracting each digit from 1. In case of nines complement, we were subtracting each digit by 9. In case of ones complement, we will subtract each digit by 1. But when subtracting binary digit from 1, we can have two combinations, either 1 minus 0 or 1 minus 1. So 1 minus 0 is equals to 1, and 1 minus 1 is equals to 0, which causes the bits to change from 0 to 1 and 1 to 0. Means what we are doing, if the current bit is 0 and when we subtract it from 1, then the resultant will be 1. If the current bit of the number is 1 and we subtract it from 1, then the resultant will be 0. That means we can obtain ones complement by interchanging zeros by 1 and ones by zeros. So therefore, ones complement of a binary number is found by changing ones to zeros and zeros to 1. That is the very simple. We have to change the value of the binary number. Now take an example. Suppose we have to calculate the ones complement of the number, and the number is given 1011000. So what we do, we just change zeros by 1 and 1 by 0. Now this 1 is replaced by 0, the 0 is replaced by 1, and the number becomes 0100111. It's a just simple mathematical manipulation. We have complemented the value, that means 0 is replaced by 1 and 1 is replaced by 0 in the current number, and the resultant number is your ones complement of any number. Now again, suppose one's complement of 0 1 0 1 1 0 1. Again we are changing the bits. It is 1 0 1 0 0 1 0. That's pretty much simple. Similarly, the r minus 1's complement of octal or hexadecimal number is obtained by subtracting each digit. In case of octal number, we'll subtract each digit by 7, and in case of decimal number, we'll subtract hexadecimal number, we'll subtract each digit by f. Because the base is 16, then r minus 1 is 15, and 15 is represented by f. So we'll subtract each digit by 15, and the resultant number will be 15's complement, or in case of octal number, it will be 7's complement. And now come to the another type of complement, that is the radix complement, or we say it as r's complement. Now the r's complement of an n digit number n in base r is defined by r to the power n minus n for n is not equals to 0, and 0 for n equals to 0. If the number is 0, means all bits in the number are 0, then its r's complement will be 0. If all bits are non-zero, if the number is non-zero, then the r minus 1's complement will be represented by r to the power n minus n. Thus, the r's complement is obtained by adding a 1 to the r minus 1's complement. So it is very much simple. If first, if we have to calculate the r's complement of any number in any number system, so what we do, we just calculate the r minus 1's complement and just add a 1 to the resultant, and the final answer, the final sum obtained by adding 1 will be the r's complement. So it can be represented like r minus r to the power n minus n. Here r is the base, n is the number of digits, and this capital N is your given number. Then r, it is calculated as equals to r to the power n minus 1 minus n. This is your r minus 1's complement plus 1. So what we do, we just first calculate r minus 1's complement, and r minus 1's complement is simply obtained in case of decimal number, subtract each digit by 9. Is in case of binary number, just interchange the zeros by 1 and ones by zeros. And in octal number, each digit is subtracted by 7. In hexadecimal number, each digit is subtracted by 15. So find the r minus 1's complement and just add 1. Now for the decimal number, suppose we have to find out the tens complement of, here is the r's complement, and the radix is 10, or base is 10 in decimal number. So we say tens complement of, we have to find out this particular number, 0 1 2 3 9 8. So what we do, r to the power n, so it will be, here digits are 1 2 3 4 5 6, then 1 followed by 6 zeros minus this number will be your resulting 987602. This is from the for the case of just mathematical manipulation. So the nines complement of this number is what, how we obtain, we obtain subtracting each digit by 9. So here 9 minus 8 is 1, 9 minus 9 is 0, 9 minus 3 is 6, 9 minus 2 9 minus so sorry, 7 is missing side probably here. 9 minus 2 is 7, here will be 7. 9 minus 1 is 8, and 9 minus 0 is 9. So what we do, we obtain 9's complement, then just add. So here is 602 will be replaced, 601 it will be replaced by 602. The number will be say here 7 is missing, so it will be 987601, and the after adding 1 it will be 987602. So here what we have done, we just calculated the 9's complement, and then add 1 to the 9's complement. So again, in this case, 246700, what we do, we first calculate the 9's complement, and then it will be 753299. That will be the 9's complement. Then just it add 1. So 299 will be equals plus 1 equals to 300. Then the answer will be 75330. Now, for the case of binary number, the radix complement or the 2's complement can be calculated just like first obtaining the 1's complement, then adding 1 to the 1's complement. So here the 2's complement, if we go with the formula, it will be r to the power n. The small n is 0, 1, sorry, 1, 2, 3, 4, 5, 6, 7. Then r to the power 7 will be 1 followed by 7 zeros minus this number will get 0, 0, 1, 0, 1, 0, 0. And further we can calculate it by with the help of the ones complement. Then the ones complement of this particular number 1, 1, 0, 1, 1, 0, 0 will be just replace zeros by ones and ones by 0. It will be 0, 0, 1, 0, 0, 1, 1. So 0, 0, 1, 0, 0, 1, 1. That is the ones complement. And just add 1 to the ones complement. It will be 1 plus 1 is 0. 1 is carry. 1 plus 1 is 0. 1 is carry. So 1 comes here. 1 plus 0 is 1. Then this 0, 1, 0, 0. We can take another example. Then the 2's complement of 0, 1, 1, 0, 1, 1, 1. So we can calculate once his one's complement will be 1, 0, 0, 1, 0, 0, 0. So just adding 1, then the 2's complement will be 0, sorry, 1, 0, 0, 1, 0, 0, and here is 0, 0 plus 1 is 1. So here is the 1, 0, 0, 1, 0, 0, 1. This will be the 2's complement of this number. The subtraction of two n-digit unsigned numbers. Suppose we have to calculate m minus n, and the number base system is r. Then we are formalizing it in the generalized form. Then we'll go to with the decimal number and with the help of the binary number. Now the algorithm is like this: add the minuend m to the r's complement of subtrahend n. So what we do, we take the r's complement of this number n, then the r's complement will represent minus n. So what we do, we first take r's complement of n, then add it to the m, that is m plus, and the r's complement is r to the power n minus n. So the resultant will be m minus n plus r to the power n. Here algorithm is tough. You need not to remember the algorithm. When we come to the example, it will be very much easy how to do the subtraction with the help of r's complement. We can use both methods, r's complement and r minus 1's complement, to find out the subtraction. Then the next step will be, if m is greater than n, there will be three combination. If m equals to n, if m equals to n, then the resultant will be 0. If then two cases are there: if m is greater than n, or n is greater than m. So we consider the first case. When m is greater than n, the sum will produce an AND carry. The sum will be, if there are n number of digits, then the resultant will be n plus 1. That is called the carry, the AND carry, which can be discarded to get the result m minus n. So whatever is the carry, you forget the carry, and the exact 9 digits will be your n digits will be your resultant. Now the second case, if m is greater than n, then the sum will equals to r to the power n minus n minus m, which is the r's complement of n minus m. So in this case, what we do, there will be no carry. Now to obtain the answer in the familiar form, take r's complement of the sum and place a negative sign in front of the result. So what does it mean? If n is greater than m, suppose we are m is 5, n is 3. So 5 minus 3 is 2. So that is the case. That is the case of second, means resultant will be positive. So what we do, the whatever is the carry, we'll discard carry, and the resultant n digits are your result. Now in this same case, if we are m is 5, m is 3, and n is 5, then the resultant 3 minus 5 should be minus 2. That is the case of third step. So in this case, what we do, we take again when there is no carry, we again take the r's complement of the sum and we put the negative sign. Now let us take an example. Suppose we have to compute 72532 minus 3250 using tens complement. So first of all, we have to equalize the number of digits. Here are 5 digits and here are 4 digits. Now what we put? We put 0 before 3. Then this is your m, this is your n. Then n will be 03250. So what we in the first step we have to calculate the tens complement of 03250. So here we go, how to solve this particular. So m is 72532. Now the tens complement of n. So here in this case the nines complement will be 94769. When we add a 0 here, then we add 1 to the nines complement, then it comes to be 05769. So here is the nines complement of n. We add both. Now the resultant will be, sum is 2 5 3 8 5 7 12, 1 carry, 6 2 8 plus 1 9, 9 plus 7 is 16. So here is the, here in this case m is greater than n, m is greater than n. So here is carry 1 2 3 4 5 6. The number both numbers was of 5 digit. So the 6 digit will be discarded. So we discard the carry and the answer will be 69282. That will be the exact answer. If you calculate with the direct subtraction, you will get this particular answer. Now the second case, when n is n is greater than m, we have taken the same example and we have calculated, we have to compute 3250 minus 72932 using tens complement. So what we do, here is your m, we have equalized the number of digits, we have put a 0 before m, then we have to take the tens complement of 72532. So here the tens complement of 72532. So how I have calculated it? I have to first find out the nines complement, and the nines complement will be here 9 minus 2 is 7, 9 minus 3 is 6, 9 minus 5 is 4, 9 minus 2 is 7, 9 minus 7 is 2. So the nines complement is 27467 plus 1, then it comes to be 27468. So it is the tens complement of this number. So just add it, then the resultant will be 81703. There is no carry, and the reason for the no carry is because n is greater than m. So what we do, there is no end carry, we take the tens complement of this number, and the tens complement is nothing but, if I first calculate the nines complement will be, here will be 9 minus 8 1 8 2 9 6, and plus add 1, then it will be 28269. So here we can see that the answer is same in both cases, 69282, and again in this case 69282. The difference is the answer will be your negative because n is greater than m. So here we what we have done, when we are taking the we are computing a subtraction using tens or r's complement, then the operation is just adding. We need not require to design a subtractor. We whatever is your adder in your ALU in the computer, arithmetical logical unit, then in this particular ALU we need not to design any subtractor. With the help of adder we can find out subtraction and addition both operations. That is the advantage of computing complements. So in this case, note that since 3250 is less than 72532, the result is negative. Now taken another example. Then after this example, we'll wind up today's class. Now we have two binary numbers. X is 10101000 and Y is I suppose that all of you may solve this question in your notebook or any paper, so that it will be helpful to how to calculate. There will be hands-on practice. Suppose X is 10101000 and Y is equals to 10000011. So first of all, what we have to see that the number of digits in both number X and Y must be equal. So we have to look into it. Sorry, 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Okay, fine. Then the number of digits in X and Y both are 7. Then we have to perform two operations, X minus Y and Y minus X, using 2's complement. So here we need not to find out whatever number is greater, whatever number is less. If there is a carry, then discard carry. If there is no carry, you have to take again 2's complement and put a zero, put a negative sign before the result. That's a simple process. We need not to worry about which number is greater or which number is less. So first we'll calculate X minus Y. So what is the process? In this case, we have to take 2's complement of Y, then add it to X. If there is a carry, discard carry. The remaining digits are your subtraction. If there is no carry, just take again 2's complement of the sum and put negative sign. The algorithm is pretty much simple and clear. So here is X. We have calculated the 2's complement of X, and the 2's complement of X is, by first take the 1's complement, and 1's complement will be of 1's complement of Y will be 0 1 1 1 1 0 0. Nothing, I have done nothing but just complement the digits. 1 is replaced by 0, 0 is replaced by 1, then the resultant will be your 1's complement. Then just add 1. So 1's complement was 0 1 1 1 1 0 0, add 1, then the resultant will be 0 1 1 1 1 0 1. Just add it, and the sum will be 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 is 2, and 2 is represented by 0 1 0. So 0 is the sum, 1 is carry, again 1 plus 1 is 0, 1 is carry, 1 plus 1 plus 1 3, 3 is represented by 1 1. So 1 is the sum, 1 is carry, 1 plus 1 is 0, 2, 2 is 1 0, 0 is here, 1 is carry, then 1 plus 1 is 2, 2 is 1 0. So 0 and 1. So here the resultant sum is of 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there is 8 bit, 8 bit. That means there is a carry. Now what we do, we just discard the carry. Here is your carry, discard it, and the resultant X minus Y will be 0 0 1 0 0 0 1. Now suppose the second case, we have to calculate Y minus X. So here what we do, we just take the 2's complement of X and just add it to Y. So here is the 2's complement of X, and 2's complement of X is obtained by just taking the 1's complement, then adding 1 to the 1's complement. So 2's complement of X is 0 1 0 1 1 0 0. So I just simply add it like 1 plus 0 is 1, 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 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1. So the number of digits 1, 2, 3, 4, 5, 6, 7. So here is no carry. That means we have to take again the 2's complement of the sum. So the 2's complement of the sum I have taken. Just first take the 1's complement, then add it to the 1 and put the negative sign. Then the resultant is 0 0 1 0 0 0 1. That is your answer. Answer is same. In case of X minus Y, 0 0 1 0 0 0 1, and in case of Y minus X, again answer is same, but the answer is negative. So here we have put it a negative sign, 0 0 1 0 0 0 1. So in this case, when you are subtracting using r's complement, you just have to, if you have to perform x minus y, if the number is decimal, hexadecimal, octal, or binary, take the r's complement of y, add it to x. If there is a carry, discard carry. If there is no carry, then again take the r's complement of the sum and put negative sign. The algorithm is pretty much clear. We need not to confuse. Just it has reduced your hardware requirement. As in case of if you have to perform the subtraction in your computer, then you have to design an adder for the addition and a subtractor for the subtraction. So what we have done, we have just done your subtraction process with the help of the adder. That is the basic advantage or basic use of this in calculating the complements.